The last section in Chapter 9 is on dilations. So by the end of this lesson, you should be able to identify and draw dilations. So remember that a dilation is a transformation that changes the size of the figure but not the shape. The image and the preimage of a figure under dilation are similar, but they're not congruent. So remember, we talked about this in the chapter when we talked about similarity, and the difference is you have something and then you either enlarge it or reduce it. So everything lines up and you end up with just either a bigger shape or a smaller shape. So tell whether each transformation appears to be a dilation and then explain. So if we look at this first one, they look like totally different shapes. It kind of looks like somebody took this one and like squished it down on both sides to get a more square versus a rectangle. So this is not a dilation. We can say that because it's squished. Where this shape tends to line up, this triangle tends to look exactly the same as this triangle, it's just a little bigger. So we can say same shape. So a dilation, or similarity transformation, is a transformation in which the lines connecting every point P with its image, P prime, all intersect at point C, called the center of dilation. C P prime over CP is the same for every point P. So it means that whatever this distance is, and whatever this whole distance is the same for all of these points. This is also something over something. So if this is like 2 and the whole thing's 4, this could be 1 and 2. They would reduce down to the same thing. The scale factor, which is K, of a dilation is the ratio of linear measurement of the image to the corresponding measurement of the preimage. In the figure, what this reduces to, so 2/4 and 1/2, both reduce to 1/2, which is K. We'll talk more about this stuff in class and actually find this with a ruler and everything. It's just really hard to do on the notes, so we're going to wait for that. A dilation enlarges or reduces all dimensions proportionally. A dilation with a scale factor that's greater than 1 is an enlargement, or it makes it bigger. And a dilation with a scale factor greater than 0 but less than 1 is a reduction, or a contraction. So on a sketch of a flower, 4 inches represents 1 inch on the actual flower. If the flower has a 3-inch diameter in the sketch, find the diameter of the actual flower. So we can talk about the different dimensions here. So in my sketch, 4 inches is the same thing as 1 inch on the actual. So we can use this to set up a nice little proportion. If the flower has a 3-inch diameter in the sketch, what would it have to have in the actual flower? This is what we don't know. So our proportion is pretty easy to solve if we use cross products. You get 4x equals 3, and that means x is 3/4 of an inch, or we could say 0.75 of an inch. So hopefully that's nice in review. And now let's do it in the coordinate plane. So if you have a point that's a preimage under a dilation centered at origin with a scale factor of K, then the image is just you multiplying those numbers by your point, which is pretty awesome. Not a lot to remember. If the scale factor of a dilation is negative, the preimage is rotated by 180 degrees. Because remember, you're taking your point and multiplying it by K. If this K is negative, so if your scale factor is negative, you end up with a negative x and a negative y. And from our rotation chapter, you know that means that it rotates at 180 degrees. Oh. So draw the image of a triangle with vertices P, Q, and R under a dilation with a scale factor of -1/2 centered at the origin. So when I first look at this, before I draw anything else, I realize that it's going to get smaller and rotate 180 degrees. So let's make sure that that happens when I actually put the points on here. So I'm going to start at -4, 4. There's P. Q is at -2, -2. And R is at 4, 0. This huge triangle here. It needs to get half the size, and it needs to flip 180 degrees. So I'm looking for P to be somewhere over here, R is going to be somewhere over here, and Q is going to be somewhere over here. So let's make sure that that happens when we actually do this. So remember, that rule said we need to take our points, so our point like P, and all we have to do is multiply the scale factor by the point. So if you do -4 times -1/2, you end up with +2. And if you do +4 times -1/2, you end up with -2. So we can do the same thing with Q. So it's -2 times -1/2, so that gives me +1. And then I get the same thing for the other part of that point. And R, do the same thing. So 4 times -1/2 gives me a -2, and 0 just gives me 0. So my new shape is going to be at +2, -2. This is P prime. So good, it flipped 180 degrees. Q prime is at 1, 1. So again, it looks like it flipped 180 degrees. And R is at -2, 0, which is good. So we can see that clearly this triangle is smaller than the original. It should be half the size. And all of our points flipped around. They rotated 180 degrees. So that's it. You should be able to identify and draw some dilations, and we'll do much more of the drawing in class where we have actual rulers. Write down any questions you have, and we can go over them tomorrow. Enjoy your night.